Hello friends, friends here at school and friends at home. Today we're going to be doing Module 4, Lesson 10 problem set. So that means we're going to be practicing in our workbooks on the skill that we did yesterday. So let's read our learning target together because this is one of those learning targets that fits perfectly with our actual activity that we're going to be doing. Okay, on the count of one class. 3, 2, 1. We can apply the distributive property as a strategy to find the total area of a large rectangle by adding two products. So we talked about this yesterday and how it's a lot of words, but if we understand, it's really just a few steps to get the area of a rectangle. So distributive property means the break apart strategy. Very good, Raghav. And the total area of a large rectangle, that means we're going to take a large rectangle and we're going to break it apart or decompose it into two smaller rectangles. Once we do that, we will find our area of the large rectangle by adding two products. And remember, product means the answer when we multiply. Okay? So pick up your pencils and follow along, friends at home. This is page 56 in your workbook. So you can do it in your workbook and take a picture as long as it's nice and clear. Submit that to your teacher, or you can also, thank you, Mr. Ward, or you can also do it on the template that will be provided to you on Seesaw. Okay? So let's look at our first one. Actually, let's read the directions first. Go ahead and read those and see if you can tell me how many things they're asking you to do in the directions. Cam, how many things are they asking us to do? Okay, very good. The first thing we have to do is label the side lengths of the shaded and unshaded. Very good. That's one thing. What else are they asking us to do? Okay, very good. So we're going to label and then we're going to find the area of the large rectangle. How are we going to do that? By adding the area of two smaller ones. Okay? So if we look at this, what do we have? We have a rectangle, and what do we notice? It is decomposed. It's decomposed into a shaded part and an unshaded part. If I look at the big rectangle and I count the sides, then I would count 1, 2, 3, 4, 5, 6, 7, 8. How long is that side of the big rectangle? It is 8 units, okay? And we don't know what units we're using. They didn't tell us, so we're just going to call them units, all right? If I want the other side of the big rectangle, I would count across the top. 1, 2, 3, 4, 5, 6, 7. So if I wanted to find the area of the large rectangle, it is an 8 by 7, so it would be 8 times 7. This side is 8, and this side is 7. But look what they did when they shaded part of it. Freya? When they shaded part of it, they decomposed some into shaded and some into unshaded. So my 8 is no longer 8. What did 8 become? It became 5 and 3. It split my 8 up. So if you think of it like this, it took 8 and it decomposed it into 5 and 3. So now let's look and see if we can make sense of this number sentence they give us. 8 times 7 represents the entire rectangle. Trace it, boys and girls, with your finger. The entire rectangle is 8 by 7. Okay? Now, what did they decompose? They decomposed to 8. So I'm going to draw a little arrow from the 8 to 5 plus 3. Go ahead and do that. Because that shows how they decomposed the 8. All right? What does 5 plus 3 represent? It represents this 5 plus this 3, how they split the 8 apart. Okay, now, under that, they put 5 times 7. Well, what does 5 times 7 represent? 5 times 7 represents 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7. We multiplied the side lengths of the shaded rectangle. So above 5 times 7, I'm going to put an S. Go ahead and do that. Let's put an S above 5 times 7. Why did I put an S above 5 times 7? Because that represents the shaded rectangle. Now to that, that's one part. We're going to find the area of the second part of the rectangle. The second part is unshaded, so I'm going to put a U here. And why did we write 3 times 7 for this? Because the side lengths are 1, 2, 3, and 1, 2, 3, 4, 5, 6, 7. So let's look and see what we did. We took the entire rectangle, which was 8 by 7, and we split it into two smaller rectangles, a 5 by 7, which was the shaded, a 3 by 7, which was the unshaded. Now, what do you think goes on the next lines? Cam, what do you think goes on the next lines? Very good, excellent. So he said the answers, or let's use a better term. How about the products for 5 times 7 and 3 times 7? Then it's going to match our learning target exactly. So what is the product for 5 times 7? 5 times 7 is 35. To that, I'm going to add the product for 3 times 7. 3 times 7 is 21. Owen? Okay, and then I have to add those two products. So right now I'm at this part of our learning target. I'm adding those two products. 35 plus 21, you might be able to do it mentally, but if you can't, what can you do? Put your algorithm over here on the corner of your workbook, and you would get 56. The area of the large rectangle is 56 square units. Okay? Now, I want you to do one other thing. This was equal groups. We had rows with an equal number of tiles in each row, but it became part whole. It's really a two-step problem. What does 35 represent? It represents the area of the shaded. So I'm going to go ahead and I'm going to write 35 in there. What does 21 represent? It represents the area of the unshaded, so I'm going to write 21 in there. And then really what do we have? We have a part, whole. Make sense? It's kind of like a little puzzle. Yes, Cam? Oh, well, you know what? Thank you so much. I'm giving you a dojo for that. But on this one, they do have all our side lengths labeled. They have 7 going across the top, they have 5 here, and they have 3 here. I guess what you could do is you could do this and show that that whole side is 8. You want to do that? Wait, you mean 35 square units? Oh, okay, we can do that. Thank you, bud. 35 square units. You're right, you probably should do that. I always tell you how important it is to dress up your numbers when you're working together. Okay, let's look at our next rectangle, okay? So let's look at the big rectangle. Take your finger and trace it. All right? Well, if I look at this big rectangle, one side is 4, but let's count together to find the other side length of the big rectangle. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So what do we have? We have a 12 by 4 rectangle, and that's where they get 12 by 4. That represents the area of the large rectangle. But what did they do? They split it or decomposed it into a shaded part and an unshaded part. Now this one, they did not label the side lengths. Let's look at the side length of the shaded rectangle. We're missing how long it is. Go ahead and count, and we'll share what is the side length of that shaded rectangle. What do you got, Jackson? Very nice. I like your complete sentence, bud. So the other side length is 10. And that works out perfectly because guess what 10 plus 2 is? 10 plus 2 is 12. 12. So we could do another number bond here. What did we do? We took the side length, which was 12, and we decomposed it into what? 10 and 2. Go ahead and show that. Show that on your paper. We just showed how we were using the distributive or break apart strategy. Okay, so let's look at this. 12 times 4, big rectangle. What did we do? We decomposed the 12. Let's draw our arrow. What did we decompose the 12 into? What plus 2? Well, let's look at it. We decomposed 12 into 10 plus 2. So let's put our 10 plus 2 there. Now that we know how we decompose 12, now we can write a number sentence for each part. Let's make this be the shaded part. What are the side lengths of the shaded rectangle? Eli. Pardon? What are the side lengths of the shaded rectangle? 10 and 4. 10 and 4. They already have the 4 there, so we have to put in the 10. Does that make sense? What does 10 times 4 represent? It represents the shaded rectangle. Okay, so let's make sure you put an S above there. All right, now, if this is the shaded, what does 2 times 4 represent? Look at your picture. 2 times 4, that represents the area of the unshaded. So let's put a U above there. Notice each time they're making us do a little more work. Now we've got those two expressions, and now we have to find the products, right? Well, what is 10 times 4? Put your caret, and go ahead and put what 10 times 4 is in that blank. That's where those numbers are coming from. Okay, what is 10 times 4? Aubrey?
10 times 4 is 40.
Very good. Where did this 8 come from? Where did the 8 come from, Ori?
The 8 came from the 2 times 4.
Yeah, the 8 came from the 2 times 4. It's just not spaced out very well. So 40 represents the area of the shaded part, so I'm going to put 40 square units in here. 8 represents the area of the unshaded part, so I'm going to put 8 square units in here. How do I get the total for the whole rectangle? What do? We add our products, and here they are. 40 and 8. What do we get when we have 40 plus 8, everybody? 48. The area of that rectangle is 48 square units. And a lot of you don't know your 12, so that's a perfect way to decompose when you have to multiply by 12. Okay? All right, let's look at C. Ms. Zimmer, thank you. Okay, trace the large rectangle with your finger, please. Trace the large rectangle with your finger. The large one. Nope, the large one. Yeah, very good. So if we're tracing the large rectangle, that's the complete one. This is the large rectangle. Okay, and if I look at that large rectangle, this side is 1, 2, 3, 4, 5, 6. Remember, labeling the side lengths was part of our directions. So let's go ahead and label the gray part or the shaded part. Go ahead and count, class. No surprise there. How many tiles in the shaded rectangle across the top? 10. Thank you, Fran. How many tiles in the unshaded rectangle going across the top, Ori?
3.
Yeah, very good. 1, 2, 3. All right, now we have the side lengths of the shaded rectangle, 6 and 10. Now, we don't really have the other side length of the unshaded, but what is it? We can count, right? We can count, what would we get? 1, 2, 3, 4, 5, 6. Or we can also say if this side is 6, then we know this side is 6 because opposite sides of the rectangle are equal. So, 6 times 13. Well, what does 13 represent? 6 represents this side of the large rectangle, and 13 represents that entire side of the large rectangle. Well, what did they do? They decomposed it. What did they do, class? They decomposed it into a shaded and an unshaded part. So we have to take our 13 and we're going to decompose it. How did they decompose it? Look at the picture. How did they decompose 13? Khalil.
10 plus 3.
Very good. They took the 13 and they decomposed it into 10 and 3. It's right on your picture. So what do we want to add right here? We want to write 10 plus 3. If you want to do your number bond to show how they decomposed it, they took 13 and decomposed it into 10 and 3. Okay, it looks a little confusing, but when you stop and think about it, we went from 6 times 13 to 6 times 10 plus 3, which is 13. We're just showing how we decompose it. Okay, in our next line, we have to show the expression for the shaded part, and then we have to add to it the expression for the unshaded part. So go ahead and fill in the expression for the shaded part. What are those side lengths? 6 and... What are the side lengths for the shaded rectangle? Nope, the shaded one. So look at your shaded one. So it looks like some of you are having trouble with that, so I assume some of you are having trouble at home. Let's take our finger Everybody take your finger and trace the shaded rectangle. What are the side lengths of the shaded rectangle? 6 and 10. So the first one is 6 times 10. Why? Because we're taking 6 and we're multiplying it by the first side length, the shaded part. So let's go ahead and put our S above that. And now trace the unshaded rectangle. Trace it with your finger. What are the side lengths of our unshaded rectangle? Cam? Very good. So let's go ahead and label those two expressions. 6 times 10 represents the area of the shaded. 6 times 3 represents the area of the unshaded. Okay, what goes on our next line? We have to find the products of both of those. Go ahead and find your products and write them on the next line. They're both easier facts, much easier than multiplying 13 times 6. So you should have a reason for wanting to decompose. Thanks, Jeff. All right, Jackson, what did you get for the first product, the area of the shaded? And how about the unshaded, bud? Very good. And we add 60 and 18. You can do it with the algorithm. I'm going to use mental math, 78. The area is 78 square units. Let's go back up. What does 60 represent? The area of the shaded. Let's write it in there. 60 square units. What does 18 represent? The area of the unshaded. Let's write it in here. 18 square units. How do we get the big, large rectangle? We add 60 plus 8. Okay? Okay, let's go ahead and look at the next one. Count your side lengths on the large rectangle. Look at Mrs. Reed. Outline it with her finger. You can outline it too. Go ahead and count your side lengths. Don't label anything yet, just count the side lengths. Very good. Okay, so when we look at this large rectangle, eyes up here, what does 8 represent? Well, it represents the 8 on this side. 1, 2, 3, 4, 5, 6, 7, 8. So I'll label that 8. And then they have 12 written here. Why do they have 12? Well, let's count this side class together. 1, 2, 3, 4. Let's start again. I want everybody counting them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. That's where my 8 times 12 comes from. It is the side lengths of the large rectangle. But what did they do? They decomposed it into a shaded part and an unshaded part. So let's look at the first one. 8 times, well, what is the side length of just the shaded part going across the top? Just the shaded part. Lori?
10.
10, very good. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And what is the side length of the white or unshaded rectangle going across the top? Ruggo? 2, very good. And isn't that what it should be? Because 12, if we decompose it, according to our rectangle, we would decompose it into 10 and 2. So, how are we going to change our expression? We're going to take 8 times 12 and change it into 8 times 10 plus 2. All right, now, we're going to write the expression for the shaded part, 8 times 10. And we're going to put an S above it for the shaded part. And then we'll write another expression for the unshaded part. The unshaded is also 8 times 2. And you can label this side 8 if you want as well, boys and girls. And we're going to label that with a U to indicate that's the unshaded part. Go ahead and find your two products, boys and girls. And if you can add them mentally, find your total area by adding your two products. Okay, Owen, what'd you get for 8 times 10?
8.
Very good. And how about 8 times 2? Very good. And now if I add 80 plus 16, we get 96. The area is 96 square units. Now remember, I want you to use the picture. So let's go back. Where does 80 belong on my picture? It belongs on the shaded part. So let's go ahead and write 80 square units. And what does 16 represent? It represents the unshaded, so here I'll write 16 square units. And now that you see that, it's pretty evident that what do? You add those two numbers. 80 plus 16 gives you 96. If you had to do 8 times 12, unless you passed your 12s, that's a hard multiplication fact to do, isn't it? But if you decompose it, who likes multiplying by 10? Just add 0. Who likes multiplying by 2? Think doubles, okay? So, multiplying by 10 and multiplying by 2 is much easier than multiplying by 12. Matter of fact, I have a confession. I never learned my 12 timetables. I use the distributive properties to this day to figure out what is 12 times 2, okay? All right, let's go on to the next page. Quickly, fist to 5. How do we feel about decomposing a large rectangle and finding the area of two smaller rectangles and adding? Fist to 5. Remember, 5 means you could teach a classmate how to do it. Okay. All right. Now we've got a word problem. Read it quietly to yourself, and then I'll read it out loud. All right. It says Vince imagines one more row of 8 to find the total area of a 9 times 8 rectangle. Explain how this could help him solve 9 times 8. Well, let's label our side lengths on this first, okay? Owen, let's label our side lengths. Let's go across the top, boys and girls. 1, 2, 3, 4, 5, 6, 7, 8. And now let's go down the side. He has a 9 by 8 rectangle. 1, 2, 3, 4, 5, 6, 7, 8, 9. But it says right here, he imagines adding one more row of 8. Where's the one more row of 8 he added? Right here. You see the little line there that kind of splits it? So that one is a 1 by 8. Go ahead and label your side lengths. So we gotta say, how could this help him solve 9 times 8? Say he doesn't know any of his tricks for 9 times 8. Well, if he adds one more row, he doesn't have 9 times 8 anymore. What does he have? He has 10 times 8. Who likes multiplying by 10? We all do, remember? Okay, so let's write an explanation. How could this help him solve 9 times 8? Well, let's do our math first. What he's really doing is he's saying 9 times 8 equals. And let's trace that big rectangle he made. What are the side lengths of that big rectangle? They are 10 times 8. So it equals 10 times 8. And to get back to 9 times 8, what do we got to do? We got to take this last row off. We're not adding it. So we're going to subtract 1 times 8. So look at the picture. Does that make sense to you? 9 times 8 is the rectangle he wants to find. He imagined one more row, so that gave him 10 times 8. To get back to 9 times 8, what does he have to do? He has to take off 1/8. Okay? All right, now let's find our products. 10 times 8, that's easy, class. What is it? 80. We're going to subtract, what's 1 times 8? That is also easy. 8. What do you get when you take 80 and subtract 8? You get 72. So that's how he did it in his head with his math. But now we have to explain how this could help him. All right? So, if he can imagine one more row, what does he have? Then he has 10 times 8. So let's write that. If he imagines one more row, then he has 10 rows of 8. Right, small. This is going to be kind of a lengthy explanation because we have to explain all his steps. I like the way Val is writing small. And what is 10 rows of 8, boys and girls? 10 rows of 8 is, okay, so he has 10 rows of 8, but he really only wants 9 rows of 8, so what did he do next? He subtracted 1 row of 8. So if he imagines one more row, then he has 10 rows of 8, which is 10 times 8, or 80. Then he can subtract, which is exactly what we did here, subtract 1 row of 8, or 1 times 8 equals 8. And then finally, what can he do? Finally, he can subtract 8 from 80 to get 72. Nice job. All we're doing, boys and girls, is we're describing what we wrote mathematically here. He imagined 10 rows of 8. He subtracted 1 row of 8. 10 rows of 8 is 80. 1 row of 8 is 8. You subtract that 2, you will get those two numbers, you will get 72. So our last step is finally 80 minus 8 equals 72 squared. So on all the other ones we've done so far, we took a big rectangle and we split it into 2 parts and then we added. This one is different. Why? Because we took a rectangle, we added a row, we found the area of the big one and we subtracted that row we added. So it's just a little different. How many of you might use this strategy when you multiply by 9? I know there's somebody in the other class that said that's their go-to strategy. Remember all the tricks we learned for the 9s? Well, one is multiplying your number times 10 and then subtracting one of those numbers, just like we did here. 10 times 8 equals 80, subtract 1, 8, you get 72. All right, let's look at our last question. All right, number 3. Number 3 says, break the 15 by 5 rectangle. So we have a 15 by 5. If I count the size, I'm sure there'll be 15 and 5. Into 2 rectangles by shading one smaller rectangle within it. Then find the sum of the areas of the 2 smaller rectangles, which is what we've been doing all along. Find the sum of the area of the 2 smaller rectangles and show how it relates to the total area. And finally, we do have to explain. Okay? So let's start by labeling our side lengths, shall we? This is easy. Up across the top, Kaden, what's that side length? 5. Let's go ahead and label that. What's our side length of this big rectangle here going down? We should know just by reading the directions. Freya, how about this big one? If we trace it, what is it?
If you trace it, it will be 15.
15, very good. Now they're asking us to break it down into 2 smaller ones by shading part. Well, how could I break 15 down? What have we been using consistently to make our multiplication sentences easy? What factor have we been using consistently, Jackson? We have been using 10. So nice job, Jackson. On almost every example when the number's above 10, we've been using 10. So I like that, buddy. So let's count down 10. Count with me, class. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. After 10, let's draw a line. So if this is 10, what should we have below it? We should have 5. Because why? If we decompose 15, in one part is 10, the other part will be 5. And then shade it. Don't shade it real dark. You don't have to shade it completely, but we'll shade that. Thank you, Miss Erin. You could, but I want you to do what I do just so when you write it. Okay, now boys and girls, we have a large rectangle that we decomposed into two parts. Let's write a number sentence for the shaded part. So if we do the area of the shaded, I guess we better label this side 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then down here it's 1, 2, 3, 4, 5. So make sure you label those two. The whole thing is 15, but the shaded part is 10 and the unshaded part is 5. Make sure you label them. So what number sentence will we write for the area of the shaded? Well, the first side length is 10. So the area of the shaded will be 10. And what's the other side length of the shaded, Caden? One side length of the shaded is 10, the other side length is 5, so we'd write 10 times 5. Man, that's easy. What is 10 times 5, everybody? 50. Okay, now let's come down here and write area of the unshaded. So why am I writing this little s here? To show that I'm finding the area of the shaded. Next to the A down here, I'm putting a U, so that stands for area of the unshaded. Go ahead and write your number sentence for the area of the unshaded. Nice job, bud. Very good. You want to write this down? Good. Try that. Make sure you're writing it. Notice how Mrs. Reed wrote the area of the unshaded down by the unshaded rectangle. I don't have it anywhere on the page. I want to make sure I write it by the rectangle and find the area. Well, what number sentence will we write for the unshaded, Cam? Very good. 5 times 5 equals 25. And remember, boys and girls, if this side is 5, we can count this side 1, 2, 3, 4, 5. We can also look up here. If this is 5, opposite sides on a rectangle are equal. All right, so this is 25, and this is 50. How do I get the area of the entire rectangle? What will I do next? Owen, how will I get the area of the entire rectangle? This is 50 and this is 25. Please label those as such. What number sentence will I write for the whole thing? Very good. I'm going to take my two products, just like it says in here, and add them. So the area of the large rectangle will be 50 plus 25, which equals 75 square units. Okay? And if you want to come back, you can put 50 square units in the top, 25 square units in the bottom. Then it becomes really clear 50 plus 25 equals 75. Okay? Explain your thinking. What did we do? We decomposed a large rectangle into two smaller rectangles and then added our products. Okay? So we decomposed a large rectangle into two smaller rectangles and then added those products. Okay? All right, boys and girls, I hope you liked that lesson. I really like decomposing in the distributive property.